we've already done this and visualized it here. But one thing we need to consider here, how we are going to subdivide this surface. And if you follow this tutorial series or this channel, or maybe you saw this from somewhere else or you already experienced with it, what we do is we use isotrim component to divide surface, right? But this time what we'll be using is we'll be using quad panels from Lunchbox plugin. This is called Lunchbox. Maybe I can put a scroll here. Lunchbox plugin, and I can put it here, and then I can put this together so that you can always see it. What this does. Oh, by the way, if you Google this, you can find the installation files as well. So what this does, it basically takes a surface and creates U based on U and V division, creates quad panels on it, right? So what we see here, if we divide this surface with our own method, we don't have these kind of cuts, but this is good in this case because in our exercise file, we already have these cuts at the end as well. If I come over here, you see that we are having these cuts on the surface. Maybe this is the image where we can see it better. This one we see it's like a polyline. So we'll be doing the same by using this. So if I increase the number of these points, maybe I can now preview this off and maybe preview this on. So I preview this on. Okay. And what I can do here is I can divide it into U and V divisions. So let's say we will have 20 divisions here, 20 here, maybe less here, just to make sure how much we want to have in both ends. You know, we can make it even smaller, something like this, right? So we can say this is what we want to have, and that's okay. And based on this organization, what now we want to have is to create the pyramid or pyramidical geometries, right? How we will be doing that. So since these panels are our new panels, what we'll be doing is basically creating or finding their normals. Like if I draw this over here, so like if we draw a section from here, let's say, we are seeing, maybe zoom out of it. So we have surfaces something like this, right? Or maybe even whether I can go here. So one surface like, oops, this one, sorry, it's taking a bit longer. So one surface like this, the other like this, the other like this, the other like this. Like these are all the connections or the points where surfaces touch one another. And this is like this. All these surfaces have different normals, right? Like base normals. So it goes like this, it goes like this, it goes like this, it goes like this, and like this. But this is quite important for me because if I don't have this normals, I won't be able to come up with the pyramidical shapes on top of these panels. So I'll be finding its area, and based on its area, I'll be creating a surface closest point. And based on that surface closest point, what I'll be doing now is I'll be finding this point as my surface, and I'll be using this surface pieces as my surface input, and then it will give me UV point. This UV point is a good thing, but it's not sort of enough. If I grab and evaluate surface, I'll be having my surface here and UV points here. And now if I visualize my vectors, if I go to display and on the display vector, this is my point, this is my vector. So you see now my vector is looking this way. The problem with this is it seems our loft sort of flipped. So the best ways to deal with this is use a flip surface and then put it in. Has this changed? It didn't change, so maybe then our division surfaces are problematic ones. So I'll replace this. Now it works. So what we are seeing now is, you see, all the arrows are looking up, which is something I want to have. Again, since this is a visualization, I can group it here and right click to it, color, turn this into white. Okay, and preview this off for now. And all the inputs should be hidden so that we don't create sort of a mess here. Alright, so I grabbed the information here, but now what I need to do is I need to move my surfaces based on these normals. So if I grab an amplitude, okay, because my vector is my normal, and I will be using this as my motion, and then I'll be using this surface to move, right, with an amplitude. So if I put an amplitude like, let's say, oops, that's too much, like 150, you'll see that each of them is going up like this on their own vectors, right? So this is basically what we are after. But one thing we can add here is, why don't we add an attractor point, right? Let's add an attractor point on our bigger surface, this one, with an MD slider. So I'll be using an evaluate curve again, evaluate surface again. This is my surface reparameterized and my attractor point. I've already done this before, therefore I'm making it a bit fast. But if you have sort of questions or doubts, feel free to comment. I'll respond whenever I see your comment. So this is my point, and if I kind of get the closest point component to calculate the distance, this is my point and their areas are my point clouds, right? Oops, I put the wrong, sorry. So this is my closest point and these are the distances. And based on these distances, I can create an amplitude, right? So what I can do here is I can remap these values. Okay, I can say remap these values and I can grab bounds. And my target is going to be something between, oh, by the way, we can do it like, we can do it with minimum as well. We can put things inside as well, but our example doesn't have it. So let's stick to what we have. Let's say we can have, I don't know, like 25 to 50, or even less, like 10 centimeters to 30 centimeters. And this is the target, and if we move this, let's see what we are seeing. So maybe I can preview this all off, and I can preview this off. So the reds are the ones that are moving. So if we see closer it comes, oops, the closer we are to the attractor points. Oops, why it's not working? Can we put it in? Or is it too small? Is it moving? Let me quickly test this. Oh, they are not moving at all. So these are the map values between 20. Oh, the problem that we are doing is we are connecting closest point, but what we need to do is we need distances, right? So if I have my point somewhere here, you see it's now moving based on the distance that we are having. So one thing we can check here is if this distance is enough, we can make it larger or smaller. That's completely up to us, and that's going to be defining the depth of what we are actually doing, right? So that is like, this is kind of it. I'll be obviously putting a group here, putting a group here, and converting this into a group all together, and just to make sure we are making it not red, because we do have something red, maybe green. Yeah. So this is how we create the components locations with an attractor point. And in the next video, maybe I can just back a bit. In the next video, we'll take this and scale them down and then loft them on top of each other.